Hello again from Saurav Sir's classes. This is a continuation of system of equations, linear equations. And if you have watched these previous videos, then you will be able to get this. And if you haven't watched it, I will suggest you watch those videos and then you'll come to this one to maintain chronology. In any case, here we are required to find the value of k. This k, we are required to find the value of k for which this system has no solution. What does that imply? Just simply write it down in the form of a1 x plus b1 y plus c1 equals 0, a2 x plus b2 y plus c2 equals 0, and you will have a1 equals to k, a2 equal to 3, b1 equal to 2, b2 is equal to 1, c1 is equal to minus 5, and c2 is equal to minus 1. Right? Now all you have to do is, for the system to have no solution, the condition is a1 by a2 is equal to b1 by b2, which is not equal to c1 by c2. So accordingly, just put the values, and k by 3 is equal to 2 by 1, which is not equal to 5 by 1. Hence, if you just solve this for k, you will get k is equal to 6, which is the required value. Let's move on to the next sum. We have the system of linear equations ax plus by plus c and lx plus my equals n will admit a unique solution if, now the conditions are required to be derived. These are the options. You cannot guess the conditions, you will have to derive them. So similarly, like the previous sum, we will have to write this as a1x plus b1y plus c1 equals to 0, and hence we'll have a1 equals to a, b1 equals b, c1 equals minus c, or c1 equals c if we just consider ax plus by plus c equals 0. Let me get this out. And c1 equals to c, and c2 is equal to minus n, and have I missed out something? Oh yes, I have missed out. a2 is equal to l, and b2 is equal to n. Now it's easy to get confused here if you're not careful, because either you make this equation in form of this is actually an equation, right? So you equate this with 0, and then you either make this in the form of this, or you make this equation in the form of this, either this or that. The reason being, it doesn't matter which form the equation is, because the c's will eventually get cancelled out. It does not matter if this c is positive and this is negative, or this c is negative and this is positive, since the entire ratio will be negative. So we will have, the system will have a unique solution, if a1 by a2 not equal to b1 by b2 and that implies, hang on, let me just get the implies sign instead of writing again. So, and that implies A by L is not equal to B by M, or AM not equal to BL, which is the required condition, this one. Simple enough. So we'll move on to the next one. So we'll have the next is, for what value of k the equations 9x plus 4y equals 9 and 7x plus ky equals 5 has no solution. So as before, we will just simply write the condition for no solution. We'll have A1 equal to 9, B1 equal to 4, C1 equal to 9 again, and A2 equal to 7, B2 equal to K, C2 equal to 5. Since C1 is not equal to K, C2 as 9 not equal to K into 5, thus the given equation will have no solution. Thus, therefore, the given equation will have no solution if 9 by 7 equals 4 by k, or k is equal to 28 by 9. This is the required condition. And thus your sum is done. There's also the answer there. This is your answer, and that's basically it. So if we move on to the next sum, we will have, let's see what this sum says. The sum demands that determine the value of k again for which the following system of equations become consistent. Not inconsistent, consistent. Please be very careful when reading the question. Consistency. So the equations are given, and our first job is to be determine the value of A1, A2, B1, B2, C1, C2, which is equal to, and A1 is equal to 7, A2 is equal to 21, B1 is equal to -1, B2 is equal to -3, C2 is equal to -5, and C2 is equal to -3. C1 equals to -5 and C2 equals to -2. That's it. So half our job is done. We will just have to check for consistency. Now for consistency, it is sufficient, just write this down, it is sufficient to check if the system has infinite solutions. So for infinite solutions, it becomes A1 by A2 equals B1 by B2 equals C1 by C2, which is 3 by 5 equals, which becomes 7 by 21 equals minus 1 by minus 3 equals 5 by k. Just cut out the minuses and then you'll get 5 by k. And if you solve this, just equate this with any one and then you will just get k equals to 5. Equate this with this and then you will get k equals to 5. So all you need to do is put the values of k, the values of A1, A2, B1, B2, C1, C2, and then you will get 7 by 21 equals minus 1 by minus 3 equals to 5 by k. And then if you solve this, you will get k equals to 5. That's it. That's your required condition. I don't think I have the options for this, but I guess this one will do. So let's move on to the next one, which is the last one for this topic. And we have the solution of the following equations. Okay, this is one equation, 2x minus y plus z equals 3. This is the second equation, 3x plus 3y minus 2z equals 11. And this is the third equation, 3x minus 2y plus 4z equals to 1. So in fact, we have to solve a set of 3 equations. Let's see how we do that. By cross multiplication, we have x by, let's just push this upward, minus 1 into minus 2z minus 11 minus 3 into z minus 3 equals y by z minus 3 minus 2 minus 2z minus 11 equals 1 by 2 into 3 minus 1. That's it. So we have